Good afternoon, everybody. Sincere thanks from ourselves for welcoming us here today. We're going to talk to you about this UGC-UKIERI funded research project, which is termed HiFlo-DAT. That is a Himalayan flood database. So myself and Esther are going to co-present this afternoon. So let's begin. Okay. So we intend to go through what you can see on the screen. We'll give you an introduction to the project and then outline what the principal objectives and aims of this research are. We'll talk to you about the progress in the research and in particular our methods of data collection and analysis to date. We'll say something about the data sources, where we're gaining the information from. And then we will explain some of our results so far, because this is an ongoing research project. And then we'll provide you some conclusions to indicate where we intend to take the research in the future. Okay, so firstly, let's tell you a little bit about the location and the principal issue, which is flooding. So on the map, we're talking about northern India and Himachal Pradesh, and in particular, inside the red polygon, the Kullu district. And you can see highlighted on this satellite image the principal settlements. So it's within that red polygon between Manali and Kullu that we're particularly interested. Why is that the case? Well, this is an area which is dominated by the Beas River catchment. This is a mountainous river, and within it it's got some large tributaries like the Parvati River. And this entire area is subject to significant natural hazard processes. So as you can see on the screen, we're talking about earthquakes, floods, landslides, debris flows, and indeed other processes. So they're indeed examples. And all that is important in the context of society because communities are exposed to these processes. And of course, different people have different vulnerability to these processes. So the social dimensions and the economic dimensions are equally important as well. However, to better manage these challenges, which aligns with the Indian Disaster Management Plan and the Sendai framework, is this desire, this direction to achieve some resilience. So this project is about disaster risk reduction, and a powerful tool of achieving that objective is to generate resilience and reduce vulnerability. But of course, this area is not in a standstill. It is changing all the time. There is rapid economic development and societal development. So if you focus in a little bit more, obviously we've got to contain and constrain the area of investigation because it has implications on our time and resources. So we've elected to focus on two Tashils. Those are the Manali and Kullu Tashils. So why did we select those two locations? First of all, the area is renowned over time as somewhere where people have settled over millennia. So there is a lot of societal knowledge which generates records, and of course people build settlements in certain places reflecting that knowledge. But through time, there's pressure on land use, so we're going beyond those traditionally risk-adverse locations. Secondly, as we've just suggested, it's undergoing rapid and significant development. And you can see there listed some of those principal drivers. So a growth in tourism. That requires infrastructure, be that roads or hotels, water treatment plants, etc. And where you build that infrastructure and the design of that infrastructure matters in this context of disasters. But there's also, not just locally, but nationally, a real thirst for electricity. And one response to that demand for electricity is to use renewable sources and hydropower from these mountain catchments in particular. But all of these development pressures, as you can see, elevate the flood risk. So the challenge is ever changing. I also mentioned that there are many historical records. This represents a significant opportunity because those records tell us about past flood events and the impacts and consequences of those events. And it's not just about the floods, but there's meteorological data as well. So on the slide there, you can just see two examples. One is an academic journal paper published in 1848, and it details a flood near the Kullu Manali airport at Bunta. And one of those streams flooded significantly in an area where they're now proposing to extend the runway. So we have to learn from these historical sources in order that our future development is sustainable. The second one is a government report, and in there there's quite a detailed account about a flood in 1894 and the particular implications of that flood, and we'll return to that later. So by looking at these long-lost documents, we can return history's knowledge back to the present day, and we can use that in our development processes and our disaster risk reduction planning. So just zooming in on one of those, this is an account from 1894, and I'll read it to you. What does it say? The extraordinary flood of black liquid mud in the Phojal in July last might be abruptly termed a calamity of the season. The exact cause has not been satisfactorily ascertained, but it is supposed that a hillside of large dimensions gave way high up in the stream, about 18 miles above its junction with the Bayas between Dobi and Katrain. The stream thus choked, held up for a few weeks, and then burst through, and it continues. So it's accounts like this that give us contemporary, detailed information about past floods and their implications. These are a rich source for future management. So floods are indeed a problem, and we can understand this problem from many sources of evidence. So, for example, the landscape is a silent witness. It records evidence of geomorphic processes. And in the photograph, you can actually see some flood deposits in the Phojal Nalla catchment. So using trees and boulder deposits and other sedimentary sequences, we're able to infer and reconstruct past floods. All this is terribly important because of these development pressures. Here, downstream on Phojal Nalla, you can see a Nepalese community alongside the river in an informal settlement. They're at a higher risk if a flood was to occur. So there's a real planning and land use question that needs to be evaluated here. But it's not just the past. It's also the present day. We're reminded of these problems. I'm going to show you just a few photographs now of a flood that impacted the region last September. So this is the bridge between Potlikul towards Naga. You can see the Bayas River. Half the bridge is missing. That impacts people's ability to move around. It affects day-to-day life, and of course it costs money to repair. Same flood nearer to Manali. This is the national highway, and you can see it is heavily destroyed. But we need to read the landscape more effectively. Here you can see a floodplain, an apple orchard, and the boulders in that apple orchard. So it's telling us something. That story needs to be understood, read, and used. Same location, a few years later, you can see some flood defence walls being constructed for a hydropower substation. Same location again, you can see that completed construction of that flood defence wall. All looks fine. What happens in September of 2018? You can see that river valley has been stripped of its trees, the river has widened, there are fresh sediment deposits. You see the evidence of a significant flood event. What did it do to that new infrastructure? Well, the retaining wall, which was around 12 metres high, has collapsed. So we need to design our infrastructure taking into account these natural and anthropogenic hazards more carefully. Going downstream further, you can see what was the NH21, now the NH3 road bridge between Dobi and Dawara. You can see potentially the Nepalese settlement underneath the bridge. You can see quite a narrow river channel. That was taken in 2012. Let's skip to 2018, same location, same bridge. You can see the impact of that dramatic flood. Again, channel widening, channel enlargement, destruction of trees, a little bit downstream, new road bridge destroyed, side of a building washed away, and many other impacts as well. So disruption, damage, cost, and indeed even worse. So in terms of understanding the history of floods, the Himachal Pradesh State Disaster Management Authority have what's called the HVRA, the Hazard Vulnerability Risk Atlas. They indeed have a collection of historical information about floods. And you're looking here at an output from that atlas. And what I want to draw your attention to are the red dots. So we've zoomed in on the Kullu Valley in the Kullu district. The red dots at the base are approximately in the region of Kullu, but you will notice there are no red dots to the north of Kullu. However, I've just shown you photographs and historical accounts of floods in the Phojal Nalla catchment, which were indicating the location of there, yet it is not in the state database. So the point I'm making is we need to add more data to this database in order that it can be more powerfully used in our development and disaster risk reduction planning. And this is indeed the Phojal Nalla catchment from the opposite side of the valley. And just to stress the point we've just made about floods that are not in the database, you can see here a few of the significant events, and this is not all of them, in that catchment. So 1894 we mentioned from the documentary account. Well known, 1905 Kangra earthquake led to landsliding and flooding in the catchment. More recently, the road bridge, which you've seen photographs of, was washed away numerous times in the 1950s. And more recently, 1994, a fatal flood killed 11 people. And we've mentioned floods in 2018. And that information is in the public domain. So it's got to be transferred to these management databases. So what are we going to do with this knowledge? Where are we heading in this project? So what are our objectives and why is this beneficial? Principal reason at the outset, people, community, society. That is a very powerful and strong driver for wanting to better manage these challenges, to defend people's lives, their livelihood, their well-being. So let's break that down a little bit. The project has 3 objectives. And the first one is to construct this new database, which we've termed HiFlo-DAT, for the defined study area of the Manali and Kullu Tashils. And in doing so, we've looked at archives, and our faculty student team have travelled between India and the UK to collect these data, principally focusing on newspapers with a few other accounts and documents as well. And that enables us to look at the linkage between flood occurrence and historical rainfall, and we'll say a little bit more about those as we go through. And we've done this not just as an academic exercise, and this is a key point to take away. In order for research to be of value, to be of use to society, we have to apply it, we have to use it. And to do that well, we need partnerships. We need to work with government agencies. We need to work with NGOs and local communities. So at the heart of our project is a partnership approach, and the workshops that we've had here in Delhi in 2018 and indeed this week have enabled those exchanges and discussions between that array of stakeholders to take place. In addition, we have to output our efforts. It's got to be in the public domain. It's got to be useful. And so we're going to present our findings using websites, social media, but also using policy-specific briefing notes, so it's useful to government agencies and NGOs. And of course, to make it more accessible, we're also going to produce a film. So it extends the availability of this information, so it has maximum benefit. Now this table, and we don't need to look at all the detail, but it breaks down the principal beneficiaries of the research. So as you can see, it benefits individuals, organisations, and indeed entire nations. And those within the red box, there are 4 which I would argue to you are principally important here. Firstly, we seek to make a difference to people's livelihoods and well-beings via these partnerships and the new data. And that's why these 2 things link. The data with disaster management agencies and NGOs enables that transference of knowledge. It makes the knowledge more readily accessible. It's not buried in dusty old libraries around the world, but it's in locations that more people can easily get at it. And that's terribly important. And it also demonstrates an India-UK partnership contribution to some global policy drivers. And you can see a few listed here, in particular the UNISDR, now the UNDRR Sendai framework, and the pan-regional implementation of that international accord, which is known as the Asian Regional Plan, which India is a central part of. So this links to a desire to make things better, but also policy. So you need to remember the importance of academic knowledge and policy and people, and this project at its heart is trying to do just that. At this point, I'm going to take a pause. I'm going to pass over to Esther, who's going to talk through about the methods and the results.
What's wrong with this then?
I don't know.
I can't do the clip. No, it's okay. I just couldn't clip it. Thank you. No, but I can stick it in my...
You're on microphone.
I can stick it in my waistband. That's what I was going to say.
Everyone's just heard that, Esther.
That's fine.
I'm pointing outwards. Speak.
Speak.
Okay, just speak louder.
Okay. So I'm now going to talk to you about the methods that we've used for our project. Okay. So we first got together in June 2018 we're at University International Guesthouse at Delhi, where delegates from the UK and delegates from India got together, and we talked about how we might approach our project. And we came up with a list of ideas that we would take forward. So that was our first step. So actually at the Delhi workshop, we got people to think about a number of questions that we posed. People worked in groups, and to make it a kind of democratic project, we actually got people to work in small groups. We gave them these sticky notelets. We call them, I've forgotten what we call them. Post-it notes, thank you. And so we got them to answer individually their ideas on post-it notes, and then to stick the post-it notes on large sheets of paper. And then we asked the group to discuss what they had all decided individually and to come up with their key facts, which we then recorded. And then we took forward, and that informed the way we went forward with our project. Okay, so the academic side of this, we actually did a massive literature search related to database protocols. So it was quite a dry subject, really, but we came up with many papers, 537 Scopus hits, out of which we filtered 310 for further review. So even that was quite a massive task to work through 300 plus papers. So it was the UK faculty and students and the Indian faculty and students. So that was quite a challenge. And we had a pro forma to work to regarding the things that we recorded, so that we had a very consistent approach to what we were doing. So we looked at a variety, as you can see on the screen, a variety of different global databases to see how they'd formulated their databases, what kind of protocols they had used. And from that, when we were working on that in Bath, in the UK, from that we came up with our ideas of how to construct our database. But before that, this was the pro forma that we used so that everybody recorded consistent information. And so then we took that forward, following that, into where we compiled the key information. So out of our original thousands of hits, we came up with 64 final assessments. Sometimes research is quite painful. Learning is painful, and that's a message that as academics we also need to understand. Okay, so I'm not expecting you to read this, not even to try. You'll probably go blind if you do. So actually this was what we came up with, and this kind of a database to work on. And it's not complete. I must stress that to you. We haven't even completed the reading yet. We haven't got anywhere near completing the database. But regarding the database design and structure, again, I'm not asking you to read these boxes in blue. But it's just to say that it's actually going to be in Excel, although we are aware that there are other dedicated database softwares. But for usability, we decided to use Excel. We will, when we get our database populated, be analysing the data that we have fairly simply in ArcGIS to produce a spatio-temporal analysis of our data. And so in this proto-database that we have, our embryo database, we've got 103 categories already into 12 different groups. Okay, so zooming in a little bit, we're looking at the database management, and there we've got things like the flood event, a record entry number, the person who entered it, when we entered it, so the metadata, if you like, surrounding the database population. And then source citation information, so if somebody wants to go back and check out that stuff, they can readily go back and find out where the records were actually held. We've got things really importantly like when did this flood happen, where did it happen, and what actually caused it, what actually happened. Thank you. And again, more of the same. What kind of damages occurred? Were there injuries? Were there fatalities? How much property, assets were lost? What the cost was? Where that information is available. Quite often that isn't available, particularly in the very historic records. Okay, so we also needed a set of governing protocols to complete our database, again, so that we could have a systematic effort at creating it. Okay, so we actually sat down, and following the June workshop and the workshop later that year in the November in Bath, we actually came up with a clear set of instructions for everyone working on the project. So as for us, as new undergraduates come through and we rope them into the project, they can know easily exactly what to do. So we had a careful and systematic assessment of all our archive sources, how we approach the reading. This sounds very standardized, but that's exactly what we wanted to do. Even down to the work ethos, the delivery dates, and the division of the source materials so that it was equitable amongst the team. So this was a pro forma that we used. This is not the database. This was a pro forma that we used to record the governing protocols. And so we record systematically exactly what we'd read. And everywhere you see a pink cell, that means there was nothing of any use to us. Where you've got a green cell, it means that there's potential information. And where there was a grey cell, there was probably no material at all. And then we checked so that we could make sure that those hits that were recorded as positive hits actually were within our study area and were interpreted correctly. So we've been very careful to try and produce a consistent, truthful result. Again, we actually decided on our governing protocols, and we adopted the same approach. So we had metadata explanation for each of the categories to guide the consistent qualitative and quantitative population of the database. And then we have a robust verification in place. And so we, for instance, we need to refine the database records where perhaps the same event is recorded in multiple times, and so on and so forth. Okay, so what were these documentary data sources? So we collected our documentary data sources in India, in the USA, and in the British Library. But principally for this project, we've collected them in the Nehru Memorial Library here in Delhi and in the British Library. And so that was what the exchange program was about. So students from India came to the UK for 1 month. A student from the UK came to India for 1 month. So we have collected, as you've heard several times, many, many years of data from 1835 to 2019. And we will continue to collect data as and when it becomes available. So one of the great things for us, being foreigners in your country, is that much of your material is in English. That enables us to do research in India. So we haven't looked at any information in any other languages. So if anyone's out there and they actually have a craving to look through the past records of Hindi newspapers, that would be great. Okay. So for this, I think it's important to also point out that we're not actually seeking local knowledge for this particular project. In our other projects, we are actually looking at local knowledge. But for this one, we're really looking at archived data information. So we've also used, apart from academic journals and newspapers, we've used books, reports, hydrometeorological data, and we've actually got stuff from the Indian government, from various libraries around the world, from various archives, from private family archives. Again, we've got links with people who lived in the Kullu Valley way back in the 1800s and who have now moved back to the UK. So we've managed to actually pick up with those people who owned that land, and they also have connections still in India, which we are yet to be able to exploit, so in the nicest sense of the word. And of course, academic publications and global database entries, as we've already said. Okay, so ordinarily I would get our students to come and talk at this point about their experiences of their exchange, but there's too much nuisance to change over the microphone. But here you'll see Pushpanjali, who's from HPU, and our student Vicky from Bath Spa Uni, and they made a great friendship while Vicky was here in Delhi. And likewise Himanshu, who's here, you'll all know Himanshu. He came to the UK with Pushpanjali, and it was great. We had a good time, and we all worked hard together to produce all this material. Okay, there's another picture of all of us at the Nehru Library, and here's a picture of some of our students and D.D. Sharma, if anybody knows D.D. Sharma, Professor Sharma at the British Library. Okay, so our data collection, newspapers at the Nehru Library and at the British Library. So these are the papers that we've looked at here. We've also been to the Tribune offices. And one of the things that you will find when you do your research is some data sources, for instance, at the Tribune was fantastically easy to use. It was searchable PDFs. So we just used a large number of search terms, and it actually did the filtering for us. So we were able to do that search of the whole of the Tribune archives in 1 week. Whereas actually for some of the older newspapers, we actually had to use microfilm, some of which were quite badly damaged, both in London and in Delhi. And so we made a decision that instead of collecting a whole year for every year, we would concentrate on the monsoon months, which would, because it was so much slower to collect that data that was in microfiche form. When we actually looked, we didn't just decide this off the top of our heads. When we looked at the material that we had already collected and at academic papers and so on, it became clear that most of the floods were occurring, quite obviously, in monsoon months. So we're not 100% confident that we've got every single flood, but we've made the best effort that we could, considering the endeavour to mine that data. So we have only interim results. Our project has almost a year to run, but these are what we've done. So we know that flood events are frequently in monsoon months, but not exclusively. That rainfall, both persistent rainfall and thunderstorms, are common flood triggers, but also by landslide lake outburst floods, earthquakes, and hydropower issues. So we know there are several different mechanisms. So notable floods, and we've already talked about this. We've got 1846, 75, 94, 1994, and that's not a typo. It happened 100 years apart. 1995 and 2018, and lesser floods in 2019. 1894 was the wettest year, with very elevated winter precipitation, snow avalanches and landslides. These events with broader footprints bring significant geomorphic change, and you saw you will have seen some of those geomorphic changes in the channel, but you all know the massive geomorphic changes on the mountainsides, where you get these extensive landslides completely obliterating roads and houses. So it's very significant for society. And so we have seen some amazing documentation, really pulls on your heartstrings documentation about the impacts of the 1905 Kangra earthquake, where people were very heavily impacted. So we must never forget the human story. We also know from the material that we've already found that there are hotspot locations for these floods. So, for instance, the Upper Beas north of Manali, in the Phojal Nalla, opposite Naga, which is why we showed you the photograph earlier on of Naga Castle. From Naga Castle, you can see straight across to the Phojal Nalla catchment, and that was a nice vantage point for us. There's a hotspot in the Savari Nalla at Kullu and in the Parvati River itself. And some of you may know about the terrible flash flooding that occurs at a place called Shat. And you may have seen photographs of that. Since 1830, and this is, if you like, a partial analysis, but since 1830, recorded floods have occurred in 13 of 19 decades. And as geographers, we like to kind of classify our work like this. It gives us an idea of the magnitude and the frequency of such events. So in 13 out of 19 decades, we've found evidence of flooding. But we need also to be mindful that there has been a huge change in either the occurrence or perhaps is it in telecommunications, in reporting and so on since the 1990s. So, for example, in September 2018, when the terrible flooding occurred in the Beas and various tributaries of the Beas, we were able to see in near real time what was going on in your country, because people were immediately posting their footage on YouTube, and we were amazed, and we kept texting each other, have you seen that? Have you seen this at Toby? Have you seen that? So information has really allowed reporting. It's citizen reporting now, if you like, of these events. So we need to be careful about saying that events have increased. It could just be reporting. So we've also used, and largely it's Rich who's done this, he's taken the daily data, the daily meteorological data from Naga Farm, and he's actually been processing that data. Huge amount of data that has taken weeks to sort and to process. Okay, so from January 1891 to May 2017. And so he has carefully checked all of the data and transcribed it, calculated it, converted it. He's looked at the accuracy. And then when we went back to the British Library in September this year, we discovered that a student who'd collected daily rainfall data in the British Library had actually not noticed that there was an errata page in many of the volumes. So we had to go back and find all the errata in the records. So he's gone through all that as well. So that's been a monumental record, and there's still a few checks to do. So the meteorological analysis then, to see if we can correlate this with flooding events. So here we've got, from the daily rainfall data, we've got monthly annual running means of the data. And there may be This is up to the 1950, and this is from the 1960s on to just about last year. And so we're hoping to get some more data, the most recent data, in the next month or two. And so we think that there's a change in the trend, but we haven't done the statistical analysis yet, and that will prove whether these slight changes are significant or not. So that's something to do in the next month or so. And these are the monsoonal data, annual data for the monsoon. I always find these graphs take quite a long time to analyse, to actually get the sense from them. And when somebody shows you this on a PowerPoint, you obviously don't have time to do it. So what I would say is, if you want to see these data yourselves, we'll leave a copy of this with Dr. Pandey, and you can have a look at them at your leisure if you are interested. Okay, so our conclusions, and they are very, very preliminary conclusions, and our next steps. Okay, so we have concluded that, and we have clear evidence, that the recorded flood impacts in a variety of different sources are far more extensive than is currently available, detailed in your official documentation. It shows, and I think this is important for you, no matter which subject you are studying, it shows the importance of looking to the historical data that we have. And your generation has a huge advantage now because so much material is available online. So it's really important to look at the historical accounts. We're not historians, but actually it's been an enjoyable thing to do for our research. We've also concluded that database construction is intensive. And so you need plenty of time to do it because it has to be right. It's no good if it's not right. So we think, and this is what we're looking at the moment, how could we scale up? How could it be possible to scale up what we've done in a very, very small part of the world, and indeed a very, very small part of India? How could we scale that up to make it more useful to society? And this morning we've had a meeting where we've discussed this issue amongst ourselves with the district disaster management authority. So we hope to come up with some good ideas for that. Okay, we have to complete the database. We will do a much more detailed spatio-temporal analysis of the flood characteristics and our flood rainfall associations. Importantly, we're going to produce a policy practice briefing note, and we're also going to make a film about the database. But this film is also associated with that. So we've been discussing as well over the last couple of days how we're going to approach our film about a database. It doesn't sound like a great idea. It's not going to be a Bollywood sellout, okay? And then we also need to think about how we disseminate our information as widely as we can so that it can be useful to society. And that concludes our presentation for today. We shall be here for a while if you would like to ask questions, make suggestions, make other comments, then we would be very happy to hear it. Okay, so I'm going to invite questions now from the audience. If you could give me your question and then I shall repeat your question so that, okay, so that everyone can hear, and so that on the film we know what the question is. So, are there any questions?
Yes, why not? From this school, geography announced issues, ask some questions.
Okay. Yes.
Please.
Ma'am, I wanted to ask that what efforts are being made to mitigate the disaster risk, and how can that data be put into use?
Okay, so the question is, what can be done to mitigate disaster risk, and how can the database help with that?
Okay, so as part of national, state, district, and indeed international protocols, there are plans in place to manage disaster risk in India. And that is a whole range of measures from before an event, during an event, and after an event. And at the heart of that is, I suppose, several principles. One principle is there is a need for different stakeholders to work together, and that's a consistent message you will see in these plans. And another message in the Asia Regional Plan is a target by 2020 for all nations to develop methodologies and provide disaster loss data. So a database about floods which develops the methods but equally provides specific data for a given place is a clear example of how we can use science in partnership with communities and government agencies and NGOs to improve mitigation. So I'd say that database can do two clear things for us. Firstly, it enables us to understand where floods have been in the past, and that knowledge enables more appropriate development plans. So, for example, it could condition areas of high risk and low risk, so land use zonation perhaps, but based in more detailed evidence. And secondly, we can use it to empower local communities to demonstrate to them that there are challenges, and it might be beyond their living memory. But here is evidence to say a long time ago there have been floods here, and thus they could occur again in the future. So it enables us to learn from the past and to bring the lessons from the past and share it with many people. So I think this sort of exercise, not only is it enabling an advancement in terms of policy, but also practice on the ground. Any further questions?
Comments, suggestions, any observations from your side?
Okay, so if there's no questions at the moment, we're very happy if you think of something in the next half hour or so that you would like to discuss with us, then please feel free to do so. Thank you.